All right, and welcome back to 5.2, where we're dealing with electron configurations, where these electrons are located around the nucleus 90% of the time. Again, we're dealing with probability areas here. And where we left off was trying to predict the electron configurations for different elements. And the first one is magnesium. With magnesium, notice that magnesium is in the third row. It's the second column over. I'm going to scroll up just to show you where it is on our map here. Okay, again, it's in the third row, second column over. Automatically, you know that it's going to end with an S2 because it's in the second column. It's in the third row, so it's got to end with a 3s2 configuration. That's where we're going for magnesium. Double check on your periodic table. So it's going to be, starting at the top here, it's going to be a 1s2, 2s2 as we go across this row here, 3s2, which is going across this block over in the blue. 2s2, 2p6, the blue, 3s2 back over here in the orange. So once again, scrolling down, the configuration for a magnesium is going to be a 1s2, 2s2, 2p6, 3s2. That is the complete electron configuration. Or you can cut it off at the next energy level, or the last energy level, and say, well, 1s2, 2s2, 2p6 is the same as neon. So magnesium has a neon core. Those are the core or kernel electrons. And then it has a 3s2 valence electron configuration. So this would be the noble gas configuration. Neon, 3s2. Okay, let's try cobalt. Cobalt, scrolling up here. Cobalt is element number 27. And it is sitting right here in the middle of the green box. It's going to end with a 3d7, so we have to do everything up to that point. Let me just change colors here. Maybe you can see as I'm going across. Let me do this in, let's try yellow. Maybe we can see the yellow. Okay, so you have a 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, the D block is one behind, 3d7. And so that would be the configuration. So as we scroll back down, let's go ahead and write that out. You should be looking on your own periodic table. You should always have one out in front of you. The configuration then, once again, can you see? Let's not do it in yellow there. Let's go back to the black. The configuration will be a 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d7. Or if you want to use noble gas configuration, that can be collapsed to an argon core. You always go back to the last noble gas that you passed. So it's an argon 4s1, 3d7. Okay? Let's try uranium. Okay, scrolling back up. Let's try, let's see, what could we use for a color? Let's go with maybe a light green, whatnot. Uranium is element 92. 92, 89, 90, 91, 92. So this would be uranium down here. Alright? And so what we're going to say is that we have a 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6, 6s2, jump down, 4f14, the F block is 2 behind, 5d10, 6p6, 7s2, 5f4. And that's where we stop, right there. All right. So again, the configuration for uranium, going back to our black, would be a 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, they're one behind, 4p6, 5s2, 4d10, 5p6, 6s2, jumping down to the F block, 4f14, they're always two behind, back to the D block, 5d10, 6p6, 7s2, jump down to the F block, 5f4. Alright, that would be the electron configuration for uranium, theoretically. Now, for those who've maybe have looked at this before or go on further, there are a lot of exceptions that happen and some funny things that happen in the F block. So we're just telling you what the trend would be and what you could predict them to be, even though technically some of these might not be exactly what they would appear to be, but that's okay. And then finally, element UUO, which is the very last element. We've actually already done this. We did this in the last lecture, but it's always good to see. The very last one is element 118. I'm going to switch this now to, let's go with a purple or a plum color. Let's see if that shows up. But if you want to get to this element down here, 118, the electron configuration would be a 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6, 6s2, jump down, 4f14, 5d10, 6p6, 7s2, jump down, 5f14, back up, 6d10, 7p6, and the entire configuration is sitting right there for you. That is the electron configuration for that last element, or the predicted electron configuration for that last element. Alright, so the whole point of this chapter was to figure out where these electrons are located, because it's the electrons that control the chemistry. What we found out is that we can't know exactly where these electrons are, but they're in probability areas called orbitals. You want to fill the electrons, or the electrons themselves will be filled closest to the nucleus and then work their way out, and they work their way out in a very predictable fashion. The electron configurations or elements of similar configurations will have similar properties, which is why we study these electron configurations. It's not just so we can rattle off a bunch of numbers and letters. It's because these similar configurations will give rise to similar properties. And that's the power of chemistry and the periodic table. If you can predict what the elements are going to do, that's how you can develop new technologies, new medicines, new techniques, etc., etc. I hope you enjoyed this chapter on electron configuration. The next chapter, chapter 6, is going to be dealing with the periodic table. We'll see you next time.